Hello, everyone. How's everybody doing? I'm Kirill Saxonov. I'm a program manager on the web platform team at Microsoft. And I'm here to talk to you about bringing your existing web app experiences over to Windows, whether they be hosted on a server somewhere or a packaged app, packaged web app, any kind of web app. It's also part of the track of the Universal Windows platform, and I can answer any of those questions as well. Generally, I like to keep these pretty conversational. We don't have a huge audience, so this would work pretty well. If at any time you have a question or you don't understand something I'm talking about or you want to ask about something I'm not covering, just let me know. Just raise your hand or say something and I'll answer it. So no worries there. And with that, I'll get started. So the first couple slides I have are just part of the Universal Windows platform. You've probably seen these already if you've been to some of these talks. But it's the promise of this one universal platform, right? You write your app. You have a set of tools that you're using to write it. And then the promise is that this app runs everywhere. It runs across multiple devices, all the devices running Windows 10. And it has access to the entire set of Universal Windows APIs. And today, we have a bunch of bridges to the Universal Windows platform. You can see the desktop bridge. We have the iOS bridge, Island Wood. The one I'll be focusing on is hosted web apps. So I'll cover hosted web apps in depth. Covering hosted web apps, you can't leave WebView out of it, so I'll cover WebView as well, how you can use it in your native apps and how you can bring web content inside your apps. And I'll also cover some emerging new standards that are coming out and what they mean for the industry and who's kind of backing them and who's starting to build them. So to begin, hosted web apps. What are they? Well, first, let's take a step back and ask, why did you choose to write a web app in the first place? How many of you here are web developers? What type of web apps do you write? ASP.NET, Angular, new frameworks, on-prem, hosted on a server somewhere. But the one main common reason that folks choose the web is because it runs across all browsers, right? And it runs across all platforms. If you're writing standards-based code, then the promise is that your code will run in standards-based browsers. The other point is you can write on any platform. Since web code is cross-platform, you don't have to develop on Windows. You can develop on Mac or Linux, the platform of your choice. And then the cool thing with hosted web apps on Windows is that if you take your web code, you can package it, and it'll run across the Windows devices. So it'll run on HoloLens. It'll run on your desktop, obviously. It'll run on Xbox, and that was a recent announcement as well with the anniversary update. The Xbox Store now accepts UWP apps. It'll run on phone, and it'll even run on a Raspberry Pi. What is a hosted web app? Kind of web apps on Windows. Well, if you're writing a website, you start as a developer with your HTML, CSS, and JavaScript code hosted somewhere on a server. It doesn't have to be an external server. It can be internal. But it's your HTML, CSS, your JavaScript code, and your other resources like images, any libraries you're loading or services you're using. And then in order to take this and make it into a hosted web app, you have to create an XML manifest. And what that allows you to do is package this, and instead of running it in the browser host, run it inside our JavaScript app host. So you're creating an AppX, and this AppX is basically running our app host, and it's navigating to your site, in this case, mysite.com. When you do that, this is a UWP app, so just like any other UWP, you get access to the entire Universal Windows platform. You get Windows Hello, you get Cortana, you get the Appointments API, and I'll show you a few demos of this throughout my talk. I have quite a bit. And then the last piece that you get is publication to the store. So once you've packaged this, you could either publish it to the external store, you can publish it to an enterprise store, or you can deploy the package in another way of your choice. So without going too slide heavy, I'm going to just switch over to a demo after I wake up my surface. All right, there we go. And I'll switch over to my machine, which is number 7. And I'll start. What I chose for my first demo is actually a ASP.NET app. It's using jQuery and jQuery UI. The way I deployed it was actually through Azure, Azure Websites, and this was a pre-existing template that was on Azure Websites. I've been signed out, but I can go back in and show you. It's not very important. I just went through the templates that existed, and this was kind of a starter ASP.NET app. I chose it and said, hey, what kind of way can I modify it to make a attractive example and show something relevant? So what I chose to do is vacation reporting. I know many of us, for the companies that we work for, have these internally. You go in and you put in your vacation dates and you submit it and someone tracks it or some internal system tracks it. So that's what I chose to create. And this template didn't originally look like this. It had like some starter pack test code up here. The first 2 bullets were get started with ASP.NET development or something. But one of the reasons I love the web is code reuse and copy and paste from different places. So the first thing that I knew I'd need is kind of like a date picker or a calendar where I can select my dates so I can go traveling somewhere. So what I have here is entry for my vacation days. And when I click, I get this calendar. I've got the site loaded so I can actually show you what's in here. When I connected to the site in Visual Studio, I opened up the solution and saw that there was a bunch of jQuery, a bunch of jQuery UI. So before I started development, I went on jQuery UI and said, hey, is there a date picker of some sort that I could reuse or an example I could use? And there was. There was a date picker, and that's what it was called. So all I did was went to this sample, copied, pasted it into my site. So I added my own JavaScript file, pasted all that code in, of course modified it to match my IDs and everything. And I had a functional date picker probably in a matter of minutes. So after that, I can select my dates, pick a date. Now this is all in the browser, so no hosted web app stuff yet. This is just my web app running in the browser. And I could submit my vacation. And the functionality I added here was integration with web notifications. So I believe all browsers now, with their latest version, support web notifications. And you can just call them. I can show you the code. I can give it access. And when I do that, I should get a notification down here. Now, what's neat about Edge is the notification is fully native. It's integrated with the system. So if I open up the Action Center and not click the notification beforehand, you should be able to see it. There it is. And it has my vacation days and everything. So it's the same native notification, not all the bells and whistles, but pretty much everything in Notification Center. So then, next step is, how do I make this into a hosted web app? So in order to do that, I will just open up Visual Studio. Go to File, New Project. And then if you go into JavaScript, Windows, Universal Apps, there is a hosted web app template. So let's just call this the time card or vacation demo. I'll create that project. Yeah, let's do those targets. I'll create that project, and the first thing you'll notice in the Solution Explorer is that it's pretty empty. The only thing in here is an images folder, which has my splash screen, tile images. I've got these error pages, offline error pages, which I'll actually demo a little bit later. But they're if the user's offline for some reason. And then the most important thing that I have is my AppX manifest. That's where you actually create a hosted web app. So in order to create one, I go to my website, copy and paste that in. So I grab my URL, paste it in as a start page, and then the one other thing that I have to do is go under the Content URIs tab, put that in there as well, and I'm going to give it Windows Runtime Access. What that does is it gives it that URL the ability to call into the UWP API set. So I'll save and hit F5. And this should launch my hosted web app. This is running as an app at this point. It's not going to be loaded in the browser. The site will be navigated to the app host, and there it is. One thing that you'll notice that's different is this Add to Calendar UI that's popped up. And I do not have that in the browser, but I do in my hosted web app. And that's because I'm doing some feature detection and then adding some Windows functionality on top where I can call UWP APIs. So if I open up my JavaScript file on my site, this is all live, so I'll try to add the actual API. You'll see that somewhere I am detecting if it's running on, let's see, right there. I'm checking for Windows, if the Windows namespace is in window, and then I am displaying that third bullet, which is letting me add to calendar. Now, there is some missing code, though. The add to calendar JavaScript code isn't there, so I'll go in and add that. To show you how many lines it is, it's not too many. I go in here. This is the entire function that allows me to add an appointment. And I'm also doing some checking in there to figure out the duration. So if I copy and paste that in, you'll be able to see it. Let me make this a little bigger. Let's see. Too big. There we go. So once again, I'm feature detecting for the Windows namespace. This lets me know that I'm running inside the app host with capabilities to call Windows APIs. And then I'm instantiating an instance of the app model appointments.appointment interface. I'm doing all this math to figure out how long the duration of my vacation is. And then I'm going to go ahead and call the appointments API with the appropriate dates, and that should do it. Now, I'll save this file, and that'll deploy live. Something you always want to do in production. And it won't be updated yet, but another neat thing about hosted web apps is you don't only have to debug through Visual Studio. The same F12 tools that exist for the browser exist for the hosted web app as well. Except I already have a script debugger attached, so I won't be able to show it in the console here. But I can go in my JavaScript console in the hosted web app, and I'll just refresh the page. So window.location.reload, and then I'll reload it not from cache. That'll refresh the page. It'll pull down my new JavaScript, the one I just deployed. So hopefully, if I pick two dates now, let's pick the Ignite dates. I'll hit submit. That just shows that I'll do another notification. There it is. If it hit add to calendar, I should get my Windows API. This is directly integrating with the Outlook calendar on Windows. I've got my duration, all-day event. I can hit accept, and that's been saved to my local calendar. So it's a nice way to extend the website where you could just submit your vacation. Now your users can actually add their vacation to their calendar as well, calling a Windows API. Any questions on that? Everybody got it? All set? Cool. Then the next thing I wanted to show is deployment on another device. So I have a phone here. The template I was using from Azure Websites is responsive. So it should look pretty good on multiple screen sizes. I'll choose deploy on device instead of my laptop here, my local machine. And let me see if I can pull up my other app so you can see my phone screen. It's deploying right now. There it is. Oh, navigation error. And this is actually a good demo of what would happen when you're offline. So let me pop open, project my screen. Nope. Let me close that app and open it up again. It doesn't look like it wants to open. Nope, it's gone. No. Man, they have to figure out a better way in search. There it is. So that's actually what I see on my phone screen. And that's the navigation error page. Those pages, the only local pages that I showed you inside the package, that's what it navigated to. Anytime there's a navigation error, the app host will automatically navigate to that page. And what that does is it lets you build an offline experience for your app. So you can navigate to pages that are coming from within the package rather than ones coming from a remote source. But my phone was not connected to Wi-Fi, so I couldn't navigate to the app. Let me see if I can connect to Wi-Fi really quickly. MSFT Wi-Fi. Should be connecting. That's fine. I can show you later if it does on another demo. Surface. All right, and that's pretty much how you take your existing web app and you create it into a hosted web app. What I showed was how you can also add a Windows integration when doing that, and what you can gain from it. Yeah, this is web applications only. What do you mean? What are you using on your server? Oh, that's fine. Yeah. Does it run in, yeah, any provided hosted app. What you're using in the back end doesn't matter at all. So you can host it wherever you like, anything. You can use Java, you can use C#, you can use JavaScript, Node.js. It doesn't matter. As long as it runs in a browser, it'll run inside the hosted web app as well. What's that? For these hosted web apps specifically, yes. Something I'll cover later in my talk shows more of the cross-platform approach of this hosted web app notion, or packaging your site or your web app-like site. So this kind of shows how we enabled all of this to work. This is just Microsoft Edge. It's powered by the Edge HTML, a rendering engine, just a standard HTML rendering engine, and Chakra, that's our JavaScript runtime or JavaScript engine. We rip those out and put them behind the app host. So you can think of it as a very lightweight browser. You're not getting all the features you would get in the browser, like history, favorites, the address bar. Those are all gone, and it looks exactly like a native app. What it also does is it gives you the capability to integrate with the platform. And the other main difference is that you can have packaged content. Just like when that phone wasn't connecting to Wi-Fi and I got navigated to the local error page, that came from inside the package. It's not something that you can do in the browser unless you're caching, things. But not all your content has to come from a remote server. The next thing I want to show is Manifold.js, and this is more along the lines of getting your web app to run cross-platform. I'm just showing another way of how you can build these apps. If I go back to my computer, I don't need these anymore. I can go to the Manifold.js website. And what this is just another tool to generate an app, a native app from your website or from your web app. So you can use Manifold.js and just give it a URL, and it will generate a web app for you. Without using Visual Studio, you can also deploy it. And the neat thing about Manifold.js is it's not only Windows, but there's multiple other platforms like iOS, Android, and Chrome. So if I hit Get Started, it'll go to that site, pull some key relevant information from a thing known as the W3C manifest. I'll go into detail about it a little bit later. But it'll get my icons. It'll read all the values. It'll set my scope, my start page URL, and any other app-like features. And then I can hit Generate Package. I won't do this right now because it takes a while. It generates packages for all platforms like iOS, Android, and all that. It's about like a 10 meg file that it downloads. But then you can take that and use it to deploy to all stores, not just Windows. Of course, it'll run on all Windows devices as well. Switching back to Surface. So kind of recapping all of the things I just talked about, what does this all mean? For hosted web apps, it means that all the code is coming from the server, just like I showed in that first diagram there. Your HTML, your CSS, and your JavaScript, all your images, they're coming from the server. And what you get with that is continuous deployment. Usually when you have a packaged app and you publish it to the store, you have to republish to the store for your code to change. Well, as part of my first demo, I just did a live code edit, and I was able to add JavaScript that actually added functionality to my app without ever repackaging it. So it's packaged once and then update, unless something is static in the package. There's no change to your existing web dev workflow. So wherever you've been hosting your code, whether it be Amazon, Heroku, Azure, it doesn't matter. What you're using on the back end doesn't matter as well. If it's running in the browser, it will run in the hosted web app host. And it's also agnostic to whatever library you're using. Angular, Angular 2 were really popular. Ember's pretty popular. React's really popular these days. So it doesn't matter what front-end library you're using. I was using jQuery and jQuery UI. The two things, yep.
How does that work with security? I know part of the thing is when the store access that is, all that stuff out. How does that work?
This slide will kind of cover it, and then I'll hit on those points. So there's two important things that differentiate your website or web app running in the app host versus it running in the browser. For one, it gives it identity. So we know when a user has downloaded it and installed it in the system. And if we have filters that detect that something malicious is going on, or the app is navigating to a malicious site, or a user reports that it's malicious, we have a kill bit to take it down, and then it stops working on every user installed machine. The other two things that take care of security is the navigation scope. When I was creating my app, I went into the content URIs, and I had to statically define every single URL that my app could navigate to. So the app host is only able to navigate to the URLs that I define. And only those URLs are able to be given Windows runtime access. Apart from that, if a user clicks a link, say, to twitter.com within my app, that'll just kick out and navigate in the browser, in the default browser, just as it would otherwise. What do you mean by dynamic?
You've got customers
Mhm. With a hosted web app, there's no great way to do that because the URLs are static, defined in the manifest. I'll go into the talk about the web view in a little bit, and you can use a web view and some APIs with it if you have a dynamic set of URLs or a URL list that keeps on changing. That's a common scenario as well. And then the other thing I just mentioned, the Windows API, the UWP API access, that's granted through the content URI rules or application URI rules in full. This is what the application URI rules actually look like inside of the manifest. So that GUI editor of the manifest that I showed you, that's just a GUI editor on top of some XML, right? So behind the scenes, the manifest is truly XML. This is what the start page looks like, where I've created mine or set mine as bing.com. And this is what the content URIs look like, or application content URI rules. You're able to define a URL that you'll match on. So say I'm creating the bing.com app in this instance. I'll have my main URL, my start page URL, be bing.com. I'll include it in my content URI rule so the app host can navigate there. And then I'll also give it Windows Runtime access, or UWP API access to the entire set of Windows APIs. But this is a common scenario as well. Say I'm doing authentication or auth, and I'm using Facebook for auth. I'll put Facebook in there as another URL that I can navigate to. Say I'm using a redirect flow. But I won't give that URL access to UWP APIs in this case. So that limits the surface area that, or the web surface area that can call UWP APIs. Another integration with Windows that I like to show is Windows Hello. So don't flip back over to my Surface. And for Windows Hello, I'm just going to use a simple banking app that our team created. So this is Bank of Contoso. This app actually uses Angular for all the UI, and it's pretty much client-side code. It's a demo app. But you have accounts, you can create an account, and you can do all sorts of things. But it gets more interesting when you package it inside as a hosted web app. So I'll go to my bank demo, and here I've done the same two things, the start page, the content URIs. I've included my banking URL, and I've given it access to UWP APIs. So if I run this on my machine, I should get the app, and then the two extra features that I get in here are bill pay and check upload. I also got a native notification, and the one neat thing if you integrate with native notifications through the UWP APIs is you can respond directly in the notification. So if I wanted to update my contact number, I could hit yes, and that'll send it to the site. Autofocus is on check upload. So I can scan a check. Let's find something here that looks like a check. Put it in front of the camera somewhere here. And this is using the native camera APIs. You could use Get User Media if you wanted to make it work in the browser. Both the native camera APIs, you get inline editing, so I can go and edit this to the check size. You could also do this automatically. And then when I hit upload check, it'll start using Windows Hello. It'll authenticate me. This is actually calling the Windows API. I've had Windows Hello set up on my machine, so it just works. And I hit OK. That'll continue and allow me to upload my check, right? Now this is a contrived demo, but you can think of where you'd want to use authentication. I'll say Windows Hello failed. I can show you the API that I actually called. If I go here, and it's the generic, credentials, key credential manager API. It'll use Windows Hello if it's set up on the machine, or it'll prompt me for my PIN, or it'll prompt me for my password if one of those fails or hasn't been set up. So this is the JavaScript code that I write, host on my server. and then it's able to integrate with Windows when running in the hosted web app. What do you think? Is that neat, or is it something you'd consider? Maybe, sometimes. Okay, the one very important thing if you go down this path and you decide to create one of these hosted web apps is to feature detect. Because you already have your website running well in the browser, you don't want to break that functionality for most of your users. If you feature detect and make sure that everything where you're calling Windows APIs is behind some check, seeing if Windows APIs are there or your site is running in the app host, you'll ensure that you don't break your website when it's running in the browser, and then it'll work just fine in the app host as well. And the next thing is local content. So even though these apps are hosted, code is coming from the server, not everyone wants to make changes or all the changes to their production sites. And there's tiers of, or levels of changes people are willing to make. So you can keep some app logic local in the package. Just like those offline error pages, you can navigate to any other page within the app. And if you want to navigate to an offline page first, make sure there's a quick load, fast page load, and show something to the user, and then go from there and navigate to a remote page. You can do that as well. The first navigation doesn't have to be remote. You can mix and match navigations, and it can be packaged only. We've had packaged apps or packaged web apps on the platform for quite a while now. I'll actually show that next. Switching over, I'll go into another demo that I made. And for this one, I'll actually go offline. So turn off my Wi-Fi. Hit run this app. And because I have this MS App error page inside my Solution Explorer, I should get a navigation error when I'm not able to navigate there because I'm not connected to the network. Let's see if it comes. Should. There we go. So I got the navigation error. I'm offline. It says I'm reconnecting. I haven't really hooked that up to anything. You can hook it up to the standard online, offline event and check for that and then try to reconnect the app. Or you can just directly navigate to another local in-package page, which I have inside my package. So this is the second offline page. It can provide a full experience. So in here, you can show dancing hamsters or play a dinosaur game or do anything you want. You can build out any offline experience from here. The other thing that's neat to show, we get a lot of feedback from developers, and if you have any, please send it or speak up. But we added a back button because in the browser, sites are so heavily reliant on the back button. We added a back button inside our app host. And if you click that, it automatically works and navigates back to the previous page, just like it would in the browser. And that's offline support. Just demoing. The next thing I want to talk about is hosted web apps on IoT. And a lot of us on the team are interested in IoT. It's cool, it's geeky, it's fun to play with. So we decided, why not create a project that shows the power of hosted web apps, shows the power of the web, and then shows the power of Windows and how you can run across multiple devices, one of which is a Raspberry Pi. So we chose to take in the concept of a magic mirror. This has been done numerous times. We can't take credit for inventing it or anything. I think one of the best ones was featured on the Raspberry Pi blog. But, and this is just a concept picture. But it'd be really neat if you had this in the bathroom, and when you're getting ready in the morning, you get in there, you're brushing your teeth, it says hello, it's giving you the weather, so you know what clothes to put on, it's showing you the time, it's giving you your travel time, and maybe some stock information. The picture is fake, like the mirror, but the UI that you see on the mirror is actually the real UI we used when we built our Magic Mirror. Ours just was a lot more cost efficient, and it was a pretty low-budget medicine cabinet from Home Depot. So this is actually the Magic Mirror demo that we built. I created a quick GIF of it. That's the mirror right there. You can see my teammate Josh going in and logging in. The first thing that you'll see is him creating a profile, and that's our Create a Profile app. So for the entire experience, we're using a Node.js website, and it's got two endpoints. One of them is the create endpoint for you to create a profile. I can show that in the browser. And then the other one is the actual Mirror UI. The Mirror UI itself is powered by a web app as well. So you're able to create a profile. We're using the face detect UWP APIs. You kind of saw that green square. It's detecting where his face is. And once he's within range, he can take a picture, submit it up to our server. Then we use the Cognitive Services APIs. And what those allow us to do is associate a face with a Face ID. Once we have a Face ID, we stick it in a database. I think for this, we use MongoDB. We put it in there. We don't store any of the pictures, so we don't get in trouble or anything. But then we're able to authenticate you, log you in, and then show you some personal information next time you're back at the mirror. So that's what you see at the end of this GIF. He comes back, he's logged in, it says, hello, Josh, and it's showing him the information that he inputted in that portal where he got to create his profile. So the reason we like this is because it showed the kind of end-to-end thinking, even though it was a low-budget mirror, or a low-budget cabinet. We did have the two-way glass. It still looked pretty decent. It wasn't great, but it showed the power of the web, a Node.js website running with two endpoints. It showed off cognitive services and how you can use, these APIs on the web to create an experience. It showed off using UWP APIs. We used the face detect because we didn't want to ping or hit the cognitive services endpoint with too many requests. We wanted to make sure that the picture we took was pretty good. There was a face in range. We weren't just sending blank pictures or pictures with no faces in them to the cognitive services API. And then we used a bunch of third-party services, right? We used service for stock, weather, maps, and traffic, all of those, kind of bringing it all in and making a concept video of it. This is all on GitHub. I believe I had a link on one of the slides. So it's an open source project. I'll actually pull it up on here. Oh, turning on my Wi-Fi would be pretty good. There we go. This is the entire project. So if you wanted to deploy this website and host it on your own server, I believe we used Heroku, you could, and then you could create your own Magic Mirror experience from this. We've got all the code in here. You have to get your own API keys, but the documentation says how to do that for cognitive services, the weather, stocks. But you can go through and do it and create your own. It'd be fun to see. If you have any issues with it or you want to send us feature requests for ours, just feel free to open them up. And I can actually show you the site running in the browser as well. So this is our kind of portal for our Node.js site. There's the create endpoint that I talked about. That's the portal. And then I've also got the mirror experience. So here's where I can create my profile. You saw that in the demo. I won't go through it. I can choose a stock. take my picture, and then you can actually also see the mirror UI, the unauthenticated mirror UI. It's flipped because when we flip the mirror, we want it to be vertical. But once you log in, you get your personalized information running down here. So that's our magic mirror running on a Raspberry Pi. If you really want to make one, I have a few Raspberry Pis handy. So if you want to try wrapping your site with me after this talk, I can give you a Pi or two. The next thing I want to talk about is hosted web apps that are available now. I talked about creating one of these, but who's actually created one and been successful with it so far? So these are all external kind of customer, consumer-facing web apps. You'll see USA, Amex, Hacker News, Shazam, Pandora on there. I'll actually go and show the Pandora app and the Hacker News app, and I think they're pretty neat stories in themselves. The first one I'll show is Pandora. So the cool thing about Pandora is that it's a true hosted app. It's not using a web view. It's just remote content loaded in. They do heavily integrate with the Windows platform, but all those API calls are coming from their server code. So they're feature detecting and then able to integrate with Cortana, pinning tiles, the SMTC, media transport control, so you can hit play pause on your hardware and it'll play pause. And then the deepest one they've done is background audio. And that has been pretty cool because they're also an Xbox app, and you can play Pandora while you're playing your Xbox game, which is neat. You can see that it's on Xbox One, on PC, and on mobile. And the one thing that allowed them to deploy across all those devices fairly quickly is because they already had an existing web app that was a responsive site and looked good across those devices. But it's one of the examples of a pretty decent one. You can see the ratings pretty good. So it's one example. The other one that I'll show is Hacker News, and let me just open that up. The cool thing about this one is that it's the same Hacker News app running across iOS, Android, and Windows. So the majority of the code is the same. It's reused web code and then loaded on in a web view or in the app host directly across all those platforms. But it as well does some Windows integrations. My favorite has to be the theming, and that's because it came with this theme originally. I don't see colors too well, so I couldn't read any of these, and you can change it. The neat thing that you'll see is the title bar color changing as well. So when you choose your theme color, it also themes the application. So it does truly look like a native app, and that's done through calling another Windows API. It's not too hard to do, but it's something you can do when you're running inside the app host versus the browser. And that's it for hosted web apps, how to create one, what's out there today, a few of the examples. These are all the resources. If you want to go and check them out, the Magic Mirror is there, intro blog, and our web app stocks. The next thing I'll go through is the web view control. And the web view is great for a few things. The web view is great for when you don't want to make your changes to your server code on your production site. Say you want to integrate with Windows, you want to create a Windows app, but you want to keep all that app logic separate and inside the package. You can do that with WebView and with a few of the APIs that it provides. It's also great for displaying any kind of web content within a native app. So if you want to add a web control or a WebView control to display an ad, you can do that. And you can also bridge the gap between web and native because of the rich API set on WebView. It allows you to communicate between your local native code and the web code running inside the WebView pretty seamlessly. When I said rich API surface, I wasn't kidding. There's quite a few APIs. I can keep going through them, but I didn't feel like making this slide any longer, so I won't. But the first demo I'll call is how you can bridge this native to web communication using a runtime component or calling any native C# or C++ component with the web view. So I'll switch over to my Surface. And I will go to that demo. It's right here. So this one, if you look in the Solution Explorer, I've got a standard XAML C# app. And then inside this project, I also have this runtime component. And this runtime component could be C# or C++. It could be any native component completing any native functionality that you may want. You may have an existing component that you want to reuse, and you can do that. So with this one, what I chose to do is use C# to generate a random number, because let's say that component was better than doing it in JavaScript, and then display the random number inside of the web view. Now, it doesn't have to be a random number generator. I don't even know if the C# one's better than the one in JavaScript. It probably is, but who knows? But there's other examples of this as well. So this one will just allow me to specify two numbers. So I'll do 1 and 1,000 and get a random number between them. And if I keep clicking that, I'll keep getting a random number. Now, the cool thing here is that if I go into my main page, .xaml, you'll see a web view control, and it's navigated to this page.html, which is a pretty simple page like you saw. But if I go into my script file, I can see that I'm calling this method off of the native object. So what I had to do for that is call the add web allowed object API that exists off of the web view. I name my native component what I would like, or how I would like it to appear into JavaScript. And then I instantiate that class from the runtime component. So if you go inside, you can see my class. There's my getRandomNumber, and I can call it directly from JavaScript code running inside of the web view. Couple things on our WebView roadmap. The biggest kind of rock that we're moving is taking it out of proc. I mentioned that one of the most popular uses was an ad control, or a WebView for an ad control. Today, the WebView runs in the same process as the app, and if that ad happens to crash, so does the entire app, because they're running in the same process. Process isolation helps with that. It helps with reliability quite a bit. If the ad control were to crash in that case, then the entire app doesn't crash. And then one API that we've added, or we're going to add with our next release, through a lot of developer feedback, is the ability to change the UA string. And what that will allow developers is to set their own custom UA string that the WebView will send with every request out to a server. Showing the power of WebView. So I showed that slide with the plenty of APIs that exist off of the WebView control. And another, let's see, another thing that got our team excited was, well, if the WebView has all of these APIs that exist off of it, can't we just build a browser with a WebView control or something similar? So we tried. We didn't make anything astonishing. This browser lacks a lot of features, but it does show that you can create something like a browser, very close to a browser with the API set that exists off of WebView. So this is an app that's in the store today. You can actually go and download it. It's called the JavaScript browser. It's also on GitHub, so all this code's open source, and you can go and play with it. But it's a pretty simple browser. We need to fix the high DPI issue that you're seeing right now. So, or if one of you wants to fix it and send us a pull request, that would be awesome. But it does favorites. You can add a favorite. These are all CSS animations, which is pretty neat. You can see the WebView still there. You can go to settings, you can clear the cache. reload the page. You can clear your favorites. And then this web view also uses a native component. And what we do here is on the app side or on the web view side, we listen for a key press, F11 in this case. And what F11 does usually in the browser is make it full screen. So we go ahead and do that automatically. But we're listening for the key press in the web view, and then we send it out to the app. Because the web view itself doesn't have the capability to go full screen, the app does. So the app is then able to handle the code. And you can see all of that and go and play with it. Like I said, it's on GitHub. Let's see. It's on Microsoft Edge again. And there it is, JavaScript browser. There's that native listener. It's just a C++ component. That's a key handler. It handles the pass-through of that key, raising events back and forth. We've got all of our main code inside of probably the JS browser and JavaScript. The other neat thing about this app is it's all written in JavaScript. So the package side is all JavaScript, and the web view is all JavaScript. So that's showing off the power of the web view. One day you'll probably be able to use it and create a browser. And because it's using the same JavaScript engine, the same Edge HTML engine as Edge, you could create the same browser if you wanted to. It does, yeah. In fact, all the UWP apps do, and then so does the WebView, EDP, and all the other security features that are being introduced come with the WebView, and a hosted web app, for that matter. I think there are different ways to mark the security feature inside of the manifest for UWP app, but I'm not too well versed on that. These are just WebView resources. If you want to look them up later, just the XAML WebView documentation, HTML WebView docs, and then the JS browser demo that I just showed. It's a Visual Studio project. If you want to run it locally, you can. And then the last thing that I'll talk about and kind of finish off with is progressive web apps. How many of you have heard about progressive web apps at all? Nothing? Okay. This is a pretty emerging standard. I think it started about a year ago, and it's very much along the lines of hosted web apps, or what I started the talk with, but it tackles the problem from a cross-platform or a standards-based solution. So if you were to create one of these apps, the promise is not only does it run across all Windows devices, it runs across all platforms as well, like iOS, Android, Mac OS, Windows Phone, all the Windows devices. And at the heart of this is, once again, a manifest, right? It's kind of appifying the web, or sometimes I like to think of it, I get frowns when I say this to web developers, but an app model for the web. And you're creating this web app manifest. It's just a JSON file that you stick up on your server, and it describes your app. It gives it its name. It gives stores and local platforms images for tiles and for things to display to the users. And it also defines the start URL of your app, kind of like I showed when we were going and creating a hosted web app in Visual Studio. So that Manifold.js demo I showed earlier, if I go back to that, you'll see what I mean. That the site I used actually had a manifest defined already, and that's what Manifold.js used to create and package the app. So that's where these images came from. That's where the scope URL and the start URL came from, and all of the other names, short name info. You can see the manifest right here. It was actually extracted and shown. And if I go to the site itself and just quickly hit F12 to debug, you'll see in the DOM Explorer, in the head section of the site, there is a manifest.json file. And this is, like I said, a web standard. It's a standard way to tackle hosted web apps. If I go off and type manifest.json, it'll actually ask me to save that. I can, if I open it, see what it opens in. Should open in code. You should see that same JSON manifest that was shown in the Manifold.js site. So it's just a way of moving even the manifest creation portion of your app up to the server and not on the client side or statically on the platform. So that's piece number one to these progressive web apps. Number two is service workers. And service workers, any of you heard of service workers? This is another new standard coming up. It's implemented today in Chrome and Firefox. We're currently implementing it. There's some preview builds available. It's behind flags. But it'll be coming in Microsoft Edge in the future as well. And what service workers give you is that final piece of the native app platform. They give you background execution, like push notification, background tasks. They give you the ability to intercept every single network request and decide what comes from the cache or what is fetched from the server. And they do that via Caches API. And they also give you the ability to create rich offline experiences without having any packaged code, because you can cache it at runtime. So in the Windows context, a progressive web app would be something like the hosted web app that I talked about, except the Microsoft Edge platform would have to support service workers. So today you can build a hosted web app with a JSON manifest or the W3C manifest. But once we support service workers, then these things just light up. And then kind of our future thinking or our vision for these is to go out there, and since everything is on the web, the manifest is out on the web, crawl them. And of course, we'd have to give the ability to developers to opt out of this inside of the manifest, or rather opt in. Like this wouldn't be done by default. But we'd crawl and index all of PWAs. And then we can run a converter to convert them over to an AppX or create that hosted web app that I showed you. And then auto-populate some store catalog. So users searching for your site wouldn't just see it in the browser. They'd be able to see it in the App Store as well, and then download it to their device directly. If you want to learn more about progressive web apps, the first blog I highly recommend. It's pretty good. And then if you're like watching videos to learn, the Progressive Web App Summit is pretty neat and covers a lot of videos there as well. So that's it. That's my talk on the state of web apps, or kind of the web today. Standard eval slide. Thanks everyone for listening.